I'm Andrew Hall from North Carolina State University. My poster's on determining spatial patterns and life cycle statistics for tracks of convective cells observed by radar in the Northwest, specifically Portland, Oregon. So our domain for the study was the Portland radar domain and the Northeast quadrant. We eliminated the Northwest quadrant because of radar blockage issues. Was identifying convective cells inside of the base reflectivity. We use a 11-kilometer diameter, convert this field into a 3-color field, with the light blue as stratiform precip, the dark blue is the convective cells that we want to track. We link these images up in time, and by minimizing the total distance traveled between cells, we come up with cell tracks that would track an individual feature through its life cycle. So for the 12-hour period, 19 March 2007, we identified 195 paths that had at least 3 frames, at least 3 nodes, so at least 18 minutes of life, and only 40 tracks that had at least 6 nodes, or 36 minutes of life. So we used those longest 40 tracks to try to see if there was any statistical results that we could show. To ourselves that we weren't tracking a feature, here's north-south cross sections along a track, and so this is earlier and later. So we see that we're tracking the feature in the middle here pretty well, and then it's visually it's different from its surroundings. To better visualize the data, here's a map, longitude and latitude. Here represents how big the convective cell is, and the color represents its intensity, its low-level reflectivity. We see there's no specific area of enhancement of size and or low-level intensity. So we view the data now by distance to the median crest, which is the red line here in the domain. So as it approaches the median crest, what happens? And so the first image here is distance to median crest and time. And we see that for the 12-hour period, there were several tracks in the first 4 hours, very few tracks in the middle 4, and many tracks in the latter 4, implying that there was something that changed throughout the procedure. And this is one of the features that we can see with this method that just looking at the base reflectivity you can't see. The other image here is distance from crest versus DBZ. So our kind of initial hypothesis was we would expect to see enhancement as they approach the cascade crest. Our event, we see little or no enhancement as they approach the median ridge, implying that, again, for this 12-hour event, the intensity of the embedded convection wasn't tied to the orography.